So let's do some definite integrals now. Let's look at 26. So if we look at this formula, this is going to be really similar to a couple of the last ones. It is going to use that arcsecant formula. So let's tweak this so that we can rewrite it in that proper form and identify everything easily. So we can write 4x squared as 2x quantity squared. And then 9 is the same thing as 3 squared. We're just trying to force this into this form. So if we let u be 2x, then our du would be 2dx. So let's think about what we need here. So to use this formula, we have to have a u squared underneath the radical, and we have to have a u outside. If we're calling that 2xu, we're missing part of u here. We're missing that too. Now, we also need a 2dx in the top. So let's put a 2 up here too. So notice I've got a 2 over 2. So I'm multiplying this by 1. I don't need to compensate for anything out here because I've already compensated for this 2 I needed for du because I needed that 2 for the u in that denominator. So we have not changed the original problem, which is good. So let's start doing our rewrite. So if we were to rewrite this guy, we are integrating everything in the top is our du. In the bottom, we have a u square root of u squared minus 3 squared. And let's do a complete change and change our bounds. So let's look at that lower bound. We said if u is equal to, if x is equal to square root of 3, that's coming from that original lower bound, then u is going to be equal to 2 times x, which is 2 times square root of 3. So this guy is going to be 2 square root of 3. For the upper bound, we said x is going to be equal to 3. That's coming from that original problem. Then u is going to be 2 times x, which is 2 times 3, which is 6. So now using that arcsecant formula, if we integrate, we're going to have 1 over a. Our a is 3. Arcsecant, absolute value of u over a. And then remember, this is a definite integral, so we're evaluating it at a few places. So let's substitute in everything we know. So it's going to be 1/3. So I'm going to have arcsecant of absolute value of 6 over 3 minus arcsecant of absolute value 2 square root of 3 over 3. So this is going to reduce to a 2. And this is 2 square root of 3 over 3. So we need to figure out what these two pieces are. So I'm going to come over to the side and do that. Arcsecant of 2. We're setting that equal to theta. So we're asking, where is that secant equal to 2? What is that angle? If you want to think about everything in terms of sines and cosines, that's perfectly fine. So that would be equivalent to saying, where is the cosine equal to 1/2? And the cosine is equal to 1/2 if we look back at our unit circle at pi over 3. So this guy is pi over 3. Now we've got to figure out this piece. So let's do that off to the side. We're looking for the arcsecant of 2 square root of 3 over 3. We want to know what's the angle that produces that. So 2 square root of 3 over 3 is equal to secant of theta. If we want to think about everything in terms of sines and cosines, we can. Sometimes that makes it a little easier. Sometimes it doesn't. So that's equivalent to saying cosine of theta is equal to 3 over 2 square root of 3. But we need to rationalize. Let's multiply the top and bottom by square root of 3. So we're going to have cosine of theta is equal to 3 square root of 3 over 2 times 3. And notice those 3's cancel. So we're looking at square root of 3 over 2. So we're asking, where is the cosine equal to square root of 3 over 2? Cosine's the x-coordinate. That happens at pi over 6. So now we want to simplify this. We need to find a common denominator. So this is going to be 2 pi over 6 minus pi over 6. So we have 1/3 times pi over 6, which is pi over 18. So there's our final answer. That's the exact value that we're looking for. So let's look at a few more. And the next two, we're going to have to complete the square. So our goal is to take this guy and to tweak it to look like that arctan formula. And to get it in that form, we've got to figure out what is our u squared. And that's where completing the square is going to be really important. So if you remember completing the square, we're going to look at these two. We're going to take half that middle term and square it. So half of 4 is 2. 2 squared is 4. But if I add 4, I have to subtract 4 also because I'm really adding 0 to this. It's just a clever way to add 0. And we know adding 0 won't change the problem. And the reason that we would want to do that is because that will allow us then to complete the square on these pieces. So that's going to be x plus 2 times x plus 2, which is x plus 2 squared. This is going to reduce. In this case, it's going to be a plus 4. So I'm going to rewrite this so it's exactly in our arctan form. So this is going to be 4 plus x plus 2 squared. And now we're in that form for number 2. And in fact, we can rewrite 4 as 2 squared to make that a easy to identify. So let's do our u substitution. Let's let u be x plus 2. So du would be 1 dx. So we have our du. So we are good to make our rewrite. So we have a du in the top. This is going to be over 2 squared plus u squared in the bottom. So let's talk bounds. To find lower bound, if x is equal to -2, then to find u, we're going to plug that in here. So u is going to be -2 plus 2, which is 0. So there's our new lower bound. Upper bound, originally x was equal to 3. That's coming from that original problem. then u is going to be equal to 3 plus 2, which is 5. So now if we integrate using that arctan formula, it's going to be 1 over a times the arctan of u over a. And this is a definite integral, so we're integrating from, in this case, 0 to 5. Okay, so we transformed everything in the u's. No need to go back to x's as long as you tweak your bounds. So we have arctan. This is going to be a 5 over 2 minus arctan of 0 over 2. Arctan of 0 over 2 is going to be 0. So this is going to be 1/2 arctan of 5/2. So there's our exact answer. And let's look at that next one. 41. We are integrating from 2 to 3 of 2x minus 3 over the square root of 4x minus x squared dx. So you always have to keep your goal in mind. We want to try to turn this into this formula, but that's going to require completing the square. So notice we have a couple of terms on top. We have a 2x and we have a minus 3. So we have to really think about this. This is going to take a couple of steps. So suppose we let u be 4x minus x squared. So then du would be 4 minus 2x. So if you notice, we could tweak this to sort of get something similar to that. So let's do some clever stuff here. Let's rewrite this. What if we were to rewrite this as 2x What if we were to rewrite this this way? Let's factor a negative out of the top. And I'm going to pull that negative out. So now we have we factor a negative out of the top here. We have a minus 2x plus 3. Thinking about redistributing, it gives us that numerator. So I factor that negative out, and now we're going to be left with, and I'm going to change the order, 3 minus 2x here over the square root of 4x minus x squared. So just pulling that negative out almost gives us that du. Okay, but instead of a 3, we actually need a 4 here. So let's tweak this problem a little bit. Let's do something really clever and let's add 0 again. So we have 3 minus 2x in the top, square root of 4x minus x squared in the denominator. So we're going to add and subtract 1. Okay, and the reason we want to do that, our goal is to try to get that, and you'll see what's going to happen here in just a second. So now we have 3 plus 1. I'm going to group those together. I'm keeping this negative 1 by itself, because what's going to happen is we're going to split this up into 2 pieces. So now we have 4 minus 2x there, and then we still have that minus 1 hanging out in the numerator. So we have 4 minus 2x minus 1 over that denominator. Now, we do not want to combine that 4 and that negative 1, because that's just going to put us right back here, and we couldn't do anything with that in that form. So that would undo everything that we've done. We don't want to do that. But what we do want to do is we want to split this up. So we want 4 minus 2x over the square root of 4x minus x squared. And then we want a minus 1 over the square root of 4x minus x squared. So you can see how we split that guy up. And now we're going to rewrite this as 2 different integrals. So we have 4 minus 2x over the square root of 4x minus x squared minus the integral of 1 over the square root of 4x minus x squared. So we're integrating 2 pieces separately. Don't forget that negative that's hanging out here. So that's why everything is in brackets. Now, to simplify this, I am going to distribute that negative to both of these pieces. That way it makes it easier for us and we can ensure we don't lose it. And when I distribute this negative to this guy, that becomes a positive. So we're going to have 2 different pieces we've got to integrate on this guy. So we're going to do this separately. And then once we get those answers, we can add those answers together to get the final answer. So let's rewrite that first one. We can rewrite this as 4x minus x squared to the negative 1/2 times 4 minus 2x dx. So we are going to let u be that 4x minus x squared. And then du is going to be 4 minus 2x dx. So that's kind of where we started by saying, what if we let that radicand, the stuff under the radical, be u. So there's our du, there's our u. So this would end up being u to the negative 1/2 times du. And let's figure out those bounds. So looking at that lower bound, in the beginning it was 2. If we were to plug a 2 in here, we're going to have 4 times 2 minus 2 squared, which is going to be 4. And then upper bound, if x is equal to 3, that was what it was here, then u is going to be 4 times 3 minus 3 squared. So 12 minus 9 is going to be 3. So I want you to notice that our lower bound is bigger than the upper bound. So we can use those properties of integrals to flip that. And if we do, it changes the sign. So it started out being negative, it would change this guy to a positive. So when we integrate this guy, this is going to be u to the 1/2, going from 3 to 4. So this is going to be the square root of 4 minus the square root of 3, which is 2 minus square root of 3. So there's half the problem. Now let's do the other half. We've got to deal with this guy. That's going to require completing the square. We want to try to tweak this so that we can get that arcsine formula up here. So I'm going to recopy that formula to move it down. So let's tweak this guy. I'm going to factor a negative out first. So we have x squared minus 4x. And I did change the order there. So we've got to figure out what we're going to add in here. So we're going to take half that middle term and square it. Half of negative 4 is negative 2, and negative 2 squared is positive 4. But if I add a 4 here, and it's multiplied by negative, I really added a negative 4. So the opposite of adding a negative 4 is to add a positive 4. That way we don't change the problem. So now this guy's going to factor. So this is negative x minus 2 squared plus 4. And then we can rewrite that. 4 is the same thing as 2 squared. So let's do our u substitution. I'm going to do it over here. Let's let u be that x minus 2. So that's this piece in here. Then du is going to be 1 dx. So we have everything we need. Let's change their bounds. So if x is equal to 2, that's coming from the original, then u would be 2 minus 2, which is 0. And then upper bound, we're starting at 3, coming from the original again. Then u is going to be 3 minus 2, which is 1. So let's make that u substitution, and I'm going to do that here. Lower bound is 0, upper bound is 1. So this is 1 over the square root of 2 squared minus u squared du. And if we compare that to our formulas, that's our arcsine formula. So to integrate that, this is going to be arcsine of u over a. Our a is 2. And then we're going from 0 to 1. So we need arcsine of 1/2 minus arcsine of 0. So arcsine of 1/2, going back to our unit circle, the sine is 1/2 of pi over 6. The sine is 0 at 0, so we're going to get pi over 6. Now we have to put both of these pieces together, so our final answer is the lovely number 2 minus square root of 3 plus pi over 6. All right, guys, hold on 1 second. I see one little mistake we made, and it happened in the first part of the problem. I can't believe I missed this. So, going back over here to this step, when we integrate, we did the flip, right? So that changed our bound, so that's good. When we integrate, we add 1 to the exponent, we divide by the new exponent. We forgot to divide by 1/2. Dividing by 1/2 is the same thing as multiplying by 2. So then it would be 2 times this amount, which would be equal to 2 times this amount, which would be equal to 4 minus 2 square root of 3. So then our final answer would be 4 minus 2 square root of 3 plus pi over 6. So it's that nice, lovely, really strange number, which is approximately equal to 1.059. If you wanted to type that in the calculator to get a rough idea of what it looks like. So, good times. Don't forget, when you add 1 to the exponent, you have to divide by the new exponent. It's really easy to start forgetting rules when you're doing this. Take it slow. Don't do it late at night like I'm doing. And just work through the process slowly, double checking as you go. The more you do it, the more you're going to enjoy it. And the easier it will become. So the last thing we need to talk about, what if we had different problems that look like this? So there's very slight differences in these 3 problems. That first one, we just have a 1 in the numerator. The second one, we have an x in the numerator. And the third one, we have an x cubed in the numerator. And that numerator change actually changes how we can do this. And in some cases, we may not even be able to integrate based on what we have here. We may have to use different techniques that go beyond the scope of this class and gets into Calc 2. And sometimes there are formulas that we just can't integrate at all. So I actually want to start with part C. So we are integrating x cubed over 1 plus x to the 4th dx. So you have to think about, what could I possibly let u be? And we have this 1 plus x to the 4th in the bottom, and we have an x cubed on top. So let's try letting u be that entire denominator. Then du would be 4x cubed dx. So why would we try that? Well, we would try that because we almost have all of du in the top. So notice that in this case, we're missing the 4 here. We can multiply it in as long as we compensate with a 1/4. So then now if we do our rewrite, we have 1/4 times the integral of du over u. And this is actually our ln rule. When we integrate, we're going to get the natural log of u plus c. And then when we sub back in, we're going to have 1/4 ln absolute value 1 plus x to the 4th plus c. Now, notice that 1 plus x to the 4th is always going to be a positive number, so that absolute value is unnecessary in that case. If you left it, it wouldn't be wrong. Just would be, a little bit of an overkill, which is perfectly fine. So that's part C. That one ends up being the ln rule. B is different. So notice with B, we don't have an x cubed here. If we were to try to multiply by an x cubed here, or an x squared here, and then an x squared here, we end up changing the domain of the problem, because now 0 would be an issue. So you can't change the domain of the problem. That's a big no-no. So then we have to try to find something else that might work. Well, what if we rewrite that x to the 4th as x squared quantity squared? Now we can turn this into an arctan formula. let's let u be x squared. So du would be 2x dx. So that x in the numerator is actually going to be absorbed into that du. We're missing a 2. We can compensate with a 1/2. So then when we do our rewrite, we have 1/2 times the integral. All of that in the top is du. And then we have our a squared, which is 1 squared, plus u squared. So using our arctan formula to integrate, we're going to have 1/2 times, it's 1 over a arctan of u over a plus c. And then if we sub back in, we have 1/2 arctan, our u is x squared. X squared divided by 1 is just x squared plus c. So you can see how that one is a completely different animal than the last one, all because that numerator is slightly different. Now, if we look at a, so using that denominator doesn't quite help us here. Okay, we use that denominator in part C and we were able to get the ln rule. If we were to try to rewrite this as 1 over 1 plus x squared dx, we're missing part of that du if we tried to let u be x squared. Then du is 2x dx. We're missing an x here. And just like we said in the last example or example before, we can't really just multiply by 2x over 2x. Because when we do, that changes the domain of this problem. Now we've got an x in the denominator multiplied by 1 plus x to the fourth. And now we're saying 0 isn't an option. We can't plug 0 in. You can't change the domain of the problem. That's why you have to be careful multiplying by extra variables in here. There are some cases where you can. We did that with an arcsecant problem earlier, but it did not change the domain for the problem. This would be an issue because it would change the domain. So that's not an option for us in this case. So that doesn't work. We can't let that whole denominator be equal to the 1 plus x to the fourth for our u, because we would be missing an x cubed. We don't have an x cubed up here, so that's not going to work. So we're kind of running out of options here. There's really nothing else we could do to solve this. So we would say that we can't use basic techniques to solve this. This would require something a little bit more advanced. So I'm going to say we can't solve it just yet. So, and once you get to Calc 4, we'll talk about some techniques we can use. This one's actually going to require something called a trig substitution, where we can rewrite things in terms of a right triangle and do some fancy math and some trig and help us solve it. So it is something we can solve. We just can't solve it quite yet using some basic techniques. We'll see more of that in Calc 2. So good times coming up.